Hello everyone, I'm going to explain what I did for project 1 for digital logic. This is my 5th time recording this video. Cam Stadio sucks. Okay, I'll get a start. So I have a 2-bit converter K-map here. And here on the right is the functions that I derive from this K-map, which is the one for 2-bit converter. So that's pretty much what I do for 2-bit converter. And another component is that, okay, here we need to encount that greater than input, equal input, and less than input. So I also wrote a function for that. That's pretty much it for 2-bit converter, the most basic unit that we're using. And I use the test bench to check that, and I generate waveforms. They all looks correct, and okay, that's pretty good so far. And let's move on to the 2-bit comparator, which I will show you in model sim. Okay, our 2-bit comparator part 2. Okay, here I have the code over there compared to and part 2. It's going to take in G in, E in, and L in, GOL, E, O, and LO, which I stand for input, O stand for output, and takes into XY value. And XY value is defined over here. Well, in this case, it's an 8-bit number. Okay, and okay, here moves the most important part of this 2N comparator. Here you have the 2N comparator. Okay, I used generate block to generate 4 2-bit comparator and link them together and using the wires that I define up here. Okay, that's pretty much what I did for 2N-bit comparator. Okay, let's move to part 3. So part 3 asks us to do the 7-segment display, basically. Okay, and here's the module that I have for a 7-segment display, and the 2-bit comparator, 2N-bit comparator is going to call it, and in order to call this function, and this function is going to create the output to that matchups on the pin layout and create 7-segment display. And what I did is I use a bunch of if statement, and I just account for every single case, and up to when x is equal to 15. Well, not only it depends on what you're calling. You can call it with y. That's pretty much what I did for a 7-segment display. Okay, here is the 2-bit comparator for part 3. 2N-bit comparator for part 3. So it's going to take x and y. Oh, I don't want to swap it. Okay. Here's x and y is going to be a 4-bit. Both of them are going to be 4-bit values. And we don't have G in here because we want to compare something. We should set our equal input to be 1 so that it can actually compare it. So which I set it down here. As you can see, I set GN. That's actually a GN. So they are the same thing actually. Oh, I'm doing something wrong again. So here I set the equal input to be 1 in order to compare them, and for the output I have GO, EO, LO. Obvious, I need to have those, and I have displays for 7-segment. I was using two 7-segment display here, but in part 4 we are going to use 4 7-segment display. 2 of them were for the negative signs. Okay, that's what I did for this part. We're still comparing unsigned numbers, so we don't need to change many things. and this things here is going to call the 7-second display function and produce the right output so that I can actually get the nice reading at the 7-second display. Okay, here comes part 4. So part 4 is asking you to compare a sign value using 2's complement, and here, sorry, I just showed you the wrong code. This is the right one. Okay, and here you have an S over here that doesn't select the mode that you're in. So if S equal to 0, that means you're going to compare 4-bit unsigned number. Sorry, 4-bit unsigned numbers. And if S is 1, you're going to compare 4-bit signed number. So X and Y 0 is your inputs, GO, EO, and LO are outputs. And here we're going to use 4 displays. 2 of them we're going to display the negative sign. So that's pretty much it. Another thing I want to mention that is, in order to compare signed number, so you will have to make the highest bit of your number to be the inverse of itself. So let's say your highest bit, let's say you have 1000. If you're comparing sign number, you always wanna flip the first bit in order to compare it. And I drew the K map for it, and I verify it just by do my test it on my D0 board, and it works out. It turns out to be works so well. And let's go to answer some of those questions that is in part 5 and 6. Okay. Well, discuss the amount of resources that I use. I can show you here in my quarters. It says that the total logic element that I use is 41. Well, probably that's pretty much it. I don't know what else to say about it. For my first comparator, like the 2-bit comparator, I use, well, in terms of gates and input, my cost of it is about 40 per 2-bit comparator. Well, I don't know if that is good or not, but it's not FPGA resources I use as like the actual cost of it. Back is asking, let's move back here. It's asking for what are some other implementation. So first I was thinking about is, okay, just use the adder subtractor to do it. If you subtract x by y, well, if the result is greater than 0, that means x is greater than y, and etc. So that's one way to do it. And well, the FPGA resource is going to require as it's going to be larger than what we did here for sure. And if you think about, well, there's other ways to do it, which is we don't use a 2-bit comparator unit. Instead, we use 1-bit comparator unit. I think 1-bit comparator unit is very easy, and you can just do it with less gates. So that probably result in less FPGA resource that is required. But I did not actually roll the function for it, so I think 1-bit comparator is going to take less FPGA resources, but it's going to have longer time delay since you have to wait for every single gate. And the last part is asking how successful my project is. Well, my board turned out to work so well, so I think my project is pretty good. And the most difficult part is the negative sign part. Well, the signed number part is definitely hard because you need to change the your 7-second display code for it in order to display the negative sign and blah blah blah. And the other part that's very hard is recording this video. It is so hard, believe me. I tried the Cam Studio so many times, and sometimes it failed to save whatever I record. Okay, that's done. Okay, let's do our demo. Here, okay, we have our D0 board. Well, currently, this switch on the rightmost side is going to decide that what either you are comparing signed number or unsigned number. So let's do signed number first. Let's say I wanna comparing 1. Well, the left one is X, the right one is Y. Well, as you can see, the green line over there lights up. That means the one on the right is greater. Well, or you can say X is less than Y. Okay, let me turn it off. Well, if I change it to show the same thing, if I change it to a, well, cannot being shown here is actually an 8. It's so bright. Okay, whatever. And you can also do it for just focus. Also could do a hex number like F. Well, I don't want to change that bit. Hex number like F, and it's going to display all the numbers. And if I have a C, which means 12, you can see this light that lights up that, which means the left one is greater than the one on the right. Okay, that's F for signed number. Let's do some, well, that's F for unsigned number. Let's do signed number. Let's say I have, well, if I just have positive number, the left one is definitely going to be the greater one. Okay, well, I just randomly playing with it. Let's say, okay, that is going to be -1. So 0 on the right is greater, so the green light lights up on the right lights up. Okay, and if I have both set it to -1, well, that should be equal, right? That looks good. Okay, well, let's just turn all the switch on. Okay, it's gonna display -8. Well, probably you cannot see the one on the right. I have no idea why. Well, they should be equal. Okay, that's good. Well, comparing positive number and negative number, and you can tell, well, the one on the left is greater. Well, that's pretty much it. I don't know what else should I play around with it. Okay, if I just turn the S, which is the mode selection, off. Well, it's going to compare unsigned value, so it switched to a hex number, which is expected, and the one on the right is greater. So the demo should be pretty much it. Thank you for watching this video, and yeah, pretty much that's it.